For today's lesson, you will need to have your graphing calculator handy, and you're going to be taking notes just on regular old paper. Right? I didn't make you a handout today. I typed myself a handout, but didn't share it with you because you can easily write these examples down as we go over them. So our topic is solving quadratic equations, and we're actually going to look at 3 different ways to do this. We're going to solve them by hand if that's possible. And then if it's not possible, then we're going to turn to technology to help us. So the first example, I was going to start here, and then at the last minute I decided, why don't I start with something really easy? Okay, and we've been doing this for the past week or so, because an expression like x squared minus 5x plus 6, that would be like in the denominator of your rational expressions, right? You would have something like this. And then we knew that the denominator could not equal 0, right? So whatever expression we had in the denominator, we set equal to 0 and solved for x, okay? And in order to solve this, right, this one will factor very nicely, okay? So x minus 2, x minus 3, and so then the solutions to this quadratic equation are, oops, I'm sorry, that should be a minus. And so then the solutions to the quadratic equation, right, what would make this equal to 0, right? If one or both of the factors were 0, and so I would get this solution and this solution. And then what does that mean graphically? Okay, and we did look at working with polynomials. So if I were to, instead of looking at this equation, if I were to put a y here and graph it, well, notice y was 0, right? What does that mean when y is 0? That means that those are my x-intercepts when y is 0. Okay, so that means my parabola would cross the x-axis at 2 and 3. That's what that tells me. Okay, so I hope I'm starting to allude to one of the other ways that we're going to be able to solve these. If we can't solve them by factoring, I could graph the function, right? If the equation is set equal to 0, I could graph that function, and I could say, well, where does it cross the x-axis? Because that's where the y value is 0, right? That's where this is happening. Right at these points on the x-axis. Okay, so we should always, for a quadratic, we should always start by trying to factor. And if you haven't noticed over the past week or so, everywhere that I can possibly fit in some factoring, especially when a is not equal to 1, right? It's so important that you go to Calc 1 being good at factoring. So why don't you pause the video, and this one will factor. So pause the video and get this one factored and then solve. Okay, so if you're back, this will factor into this. Okay, so then we set each factor equal to 0. The one on the left you may not be able to do in your head. Some of you can, right? But what is that when I set that equal to 0? You know, obviously this one, x plus 1 equals 0. We can all do that in our head. So we know one of the solutions is x equals -1. Okay, but then for this one, I would add 3 to the other side. I would divide both sides by 2, and I get x equals 3/2. Okay, so next example over here. So this would be example 2. This would be example 3. All right, how am I going to solve this? And we're going to look at a couple different ways. So if I have a quadratic equation, I always start by seeing if it will factor. Now, I have a problem here. right? I've got the equal sign in the middle where it's, I'm not supposed to have the equal sign, in the middle like this. So what I can do then is bring all the terms over to one side and set the equation equal to 0. Okay, so add the 4x to both sides and then subtract 7 from both sides. Okay, so if I don't have that situation where all my terms are on one side, then I do that basic algebra and I write it in that form. All right, then I look at this and say, okay, factors of 7 that equal 4, not going to work. Okay, so before I turn to technology, that's one way that I'm going to show you that you could solve this. But I would not be a responsible pre-calc teacher if I let you go off to Calc 1 without being good at the quadratic formula. Okay, so if I'm solving a quadratic and it doesn't factor, I can use the quadratic formula. And I think when I show you how to do this on technology, you're going to prefer that, of course, right? That would make sense. But we do need to know how to use this formula. So here it is. Copy it down into your notes if you don't already have it memorized. I know there's some really catchy songs that you could sing. I don't have a good singing voice, so I don't sing for my classes, but I know your high school teachers, there's several different songs you can use to remember this. And actually, I think songs are very effective in helping students remember facts. Maybe I'll try to find you a link to one of those songs from YouTube. So anyway, we are going to plug into the quadratic equation. So in this case, my A is 1, my B is -4, and my C is -7. So you have to take the sign with it. Okay, so I have -b, so x equals, that's an important part as well, that x equals in front. Students often neglect this part. X equals -b plus or minus the square root of b squared, so that would be 16 minus 4, a is just 1, minus 4ac. Okay, then you have to be careful, right? Do your order of operations, and then you've got to be careful with that double negative. Oh, wait, let me do over 2a before I deal with what's under the radical. Okay, so I get 4 plus or minus. So this becomes 16. I'm going to write it off to the side in a different color marker. 16 minus 28. Okay, so that becomes plus. All right, so that will become radical 44 over 2. Okay, and then I can have different requests for how I would like the answer. Okay, maybe I'm fine with the answer like that, or maybe I say, give the answer in simplest radical form, or express the answer as a decimal to the nearest hundredth. All right, so let's take a look at all of those different forms. If I had said simplest radical form, remember, I can't divide into one term of a sum without dividing into both, right? Because I've got the plus and minus here. Can't divide 2 into this because one's under the radical and one isn't. But I could come over here and recognize that radical 44 is radical 4 times 11, right? So then that would simplify to 2 radical 11, and that would allow me to simplify this. All right, so 4 plus or minus 2 radical 11 divided by 2. I can divide by 2 now as long as I go into each part. Right, because dividing by 2 is the same as multiplying by 1/2. So another way to think of this is I could think of having to distribute the 1/2, right, through the parentheses. I have to go to both parts of this sum. All right, but this right here is a product. right? And so when I distribute a half times 2, this is all a product. Okay, and so this would result in simplest radical form, 2 plus or minus radical 11. So if I told you to change this to a decimal, right, you would need to take out your calculator, and one solution is x plus radical 11. So I separate this into the two answers. Answer is 2 plus radical 11. The other answer is 2 minus radical 11. Okay, so let's see. I'm gonna say let's round off to the nearest hundredth. So we'll say nearest hundredth for all of these for rounding. Okay, so this is doing this basically by hand, right? Up until we get to the point where we are changing to a decimal. Okay, so if we have our calculator in front of us and we want to use technology to help us, a couple different things that I could do. I could graph the function up here. So this would become a y equals. All right, I could graph this function y equals, and because I want to find the zeros of this function, I am looking for where this function crosses the x-axis, right? I'm looking for these points, right? So I would look at the graph, find the x-intercepts. That's one way to do it, okay? Here's the other way to do it. What happens here is I have two functions of x that are equal to each other. Okay, so another way that I could solve this graphically is I could graph each half of that equation separately, and I could see when they're equal to each other. So I could graph the function y equals x squared, and then I could say, all right, when is this function equal to this function? Okay, that's another way I can do this. So since we haven't experienced this yet, I'm actually going to, instead of showing you this method, I think you would understand this method from work we've already done. Let's take a look at this method together. So let's go to the graphing calculator. And sometimes one of the hardest things about doing this is setting your window. Okay, so right now I'm in the standard window. And I know that there needs to be two solutions. I have a parabola and a straight line. And so there doesn't have to be two solutions. I mean, I know that there is, though, because of already getting the answer. But I have to make sure that I adjust my window so that I can see where these functions intersect. So I have negative 4x plus 7. Okay, so I'll just try graphing it right now. Oh, you know what? Let me go to the error. I know what my error is. I put a minus sign instead of a negative. Clear negative 4x plus 7. Okay, so graph. Okay, so there we go. And I can tell something's happening off the screen that I should be aware of. Okay, so I'm going to adjust my window. So I need to make y bigger. And actually, nothing of interest is happening down here where y is negative. So when I go to adjust my window, I could make my y min maybe just like -1. Right, because I'm not interested in what's happening down in the negatives. How about I make that 20? I don't know if that's big enough yet. Sometimes it takes a little trial and error to find the right window. Nope, still not big enough. So I'm going to go. Oh, let's go 40. There we go. Okay, so now I go to second calculate right above the trace, second calculate, and I go to intersect. intersect. All right, I'm looking at where these graphs intersect. Okay, and it's asking me what's my first curve and what's my second curve. And you need to put the cursor close to the point because it'll find the intersection point of whatever it's closest to. So I'm going to move this over closer to the first intersection point. I'm going to hit enter. That's my first curve. And then it jumps to the second curve. So I hit enter, don't want to guess. And there's my intersection point of negative 5.332 approximately, if I round to the nearest tenth. Okay, so then do this again, second calc. See, this is nicer than the quadratic formula, right? I imagine you are going, if I give you something on a quiz and I say, solve it however you want, I imagine you are going to prefer to do stuff like this rather than quadratic formula, given the choice. Now on a quiz, I am definitely going to have a place where I say, solve this by the quadratic formula. Okay, so first curve, I hit enter. It jumps to the second curve. I hit enter. I don't want to guess. And there's the 1.32 that I knew was a solution. So let's go to this example. Okay, where I'm given this function and I want to know when does f of x equal -3? When does f of x equal -4? Find f of 5. All right, and I'm going to let technology help me here. Let's see. So let's start off with f of x equaling -3. Okay, so that means or +3, I'm sorry. So that means I have to plug in a 3 for f of x. And lots of students get here and are kind of stumped, right? They don't know what to do next, right? Because this is not a nice looking equation. Okay, but what I want you to do is think back to middle school when you learned how to cross multiply, right? So put this over 1 and then you're cross multiplying, right? Multiply this times this and this times this. Okay, so you would get x squared minus 2. And then over here, you would get, make sure to distribute 3x plus 6. Okay, and right now I have a whole bunch of choices for what I could do. Okay, if I wanted to right now, I could graph this. I could graph this and see where they cross. Okay, or I could bring all the terms over to one side. And it's not going to factor, but I could use the quadratic formula. Right, so that'll be -3x. Let's see, when I subtract 6 from both sides, I get -8. So I could use the quadratic formula. Or that when I solve this graphically, I actually could have started right up here. I could have taken out my graphing calculator and I could have typed in y equals 3. And I could have also typed in y equals this, right? And looked to see where they intersected. All right, so I could do that, or I could type y equals, and then I could type this side, and then I could type this side, or I could type in this whole function, right? And put it in terms of y equals, and then find the zeros. Let's do this though. Let me encourage you to practice the quadratic formula for a minute. Okay, so if you will pause the video and try this by the quadratic formula, just to make sure you're good at that. All right, and then we'll go to technology and take a look at this. Okay, so if you're back, when you use the quadratic formula, you would get this. And if you change that to a decimal, you would get 4.7 and negative 1.7. I have something here in my notes, though, warning you about the calculator. When you type this into your calculator, it's very common for students to type it like this. They will type 3 plus radical 41 divided by 2. Right? They'll type that right in on their calculator. What you have to know about your calculator is it knows order of operations, and it will grab this first. It will do the radical 41 divided by 2 and then add the 3. Okay, and you don't want that. You want to do the entire numerator first. So just hit enter after the numerator and then divide by 2 or put it in parentheses. So let's take a look at doing this graphically, because we also want to know, when does f of x equal -4, right? Put in -4 for f of x. So it might be easier, if I want to do this all at once, to take that graphing calculator and plug in this function, okay? Because then another thing I want to find is f of 5, all right? That's not too hard to do, right? F of 5 just means plug in 5 for x, right? F of 5, you know, so if I want to find functional values, that just means plug in, right? That would just mean 5 squared minus 2 over 5 plus 7. I'm sorry, 5 plus 2, which is 7. So that'll be 23/7. Okay. But one other thing that I want to show you is when I put this in on my calculator, say I want you to find a whole bunch of functional values. That's where table is really nice on the calculator. So let's go to the calculator. Let me share that screen. Okay, so clear everything. And I'm going to put my window just back to a Zoom 6, Zoom standard, just as a starting place. All right, I may or may not want to adjust that. All right, so under y equals, make sure you're using parentheses for the numerator and denominator, so you get that quotient that you want. So x squared minus 2 divided by parentheses x plus 2. Right? And then in y2, I am going to put 3 because I want to know when this function equals 3. And I also want to know when this function equals -4. All right, so let's take a look at the graph and then I'll decide if I have to adjust my window. Okay. And I don't need to. I'm in a good window, and the red line is y equals 3. And so I can see 2 solutions to that. Notice, when does f of x equal -4? This is this line right here. Okay, I could zoom out on the function to verify this because you might be wondering, well, maybe I just don't see it on the screen. But this function, which is in blue, that's the rational function that I'm considering, that never crosses the value of y equals -4. What that means is that y equals -4 is not part of the range of the function. All right, so again, when I want to find where those lines intersect, I go to second calculate, intersect. I'm going to move my cursor closest to the one on the left because I'll start there. Oh, and it doesn't matter if I'm up there, down below. Enter, second curve, enter, don't want to guess, and I get -1.7. Okay, so I'll let you find the other point on your own and match it with what we saw on the front page. Okay, but I also had asked you to find f of 5. And so the nice thing that you can do is since I put in that function, you can go to table. And, oh, so I've got a weird table set going on here, don't I? I think it might still be set from that bowling example. So go to second table set and I'll just start at 0. Right, and I'm going to go to auto. Okay, and then I'm going to see all of the functional values starting at 0. So f of 0 is -1. I asked you for f of 5, which would be that decimal approximation. So anytime I ask you for functional values, you don't have to, take the time to plug them in and do the arithmetic. If you want to put them on, type this into your y equals and then just use table. Right, that's a time saver. So I think it's time for a break, and we will pick up with more of this in the next section.